Hello again, everyone. Dr. Tom McNamara here for our course in trigonometry. I'm going to be working with Desmos again in this video, and I wanted to continue to build on what we had discussed in the last few videos, and that is graphing. Now, we had been working with changes to the amplitude and period of a function. So multipliers on the outside of a function change the amplitude, they make the function taller. Multipliers on the inside mess with the period, the horizontal dimension, the cycle length. So amplitude changes the height, changes to the period, alter the cycle length. You notice that was all multiplication. There was no adding and subtracting. So I want to review the types of changes that we see in graphs when we add or subtract in various parts of a formula. So let me get out of the way here. And let's go ahead and do some graphing. So let's not even, okay, let's do those minor grid lines. I kind of like them. Okay, so I want to graph a non-trig function for right now. Y equals x squared. Okay, I'm sure you remember this from your algebra. It looks like it's actually off the bottom of the screen. Let me can I change that somehow? Okay. All right, that's looking a little more like what I want. Okay, so here we've got the graph of y equals x squared. You probably remember this from your algebra class. It's a U-shaped graph called a parabola. So 1, 1, that's on the graph because if you square 1, you get 1. 2, 4 is on the graph because if you take 2 and square it, you get 4. 3, 9 is on the graph because 3 squared is 9. Okay, easy enough. Now I want to show you this here. Let me do. We're not going to do x squared. We're going to do x minus a squared, and we're going to add a slider for a. Let me change the settings on my slider, so we'll make the values of a go from 0 to 5 with a step of 1. Okay, so we're going to be bona fide subtracting something here. So this is just the regular x squared graph. Okay, now notice what happens when we do x minus 1 squared, x minus 2 squared, x minus 3 squared, x minus 4 squared, x minus 5 squared. Okay, so I call this a subtraction on the inside. Okay, you're changing the input of the function. So that is going to affect the x-axis. Okay, the x-axis on your function's graph represents the input. Let me come back here. Nope. Get the window here. Get me there. Come on. Move me over to the side. Okay, so when you change the input to the function, that should affect the x-axis because on the graph, the x value represents the input to the function, like we were talking about right here. 2, 4 is on the graph because if you put 2 into the squaring function, you get 4. 2 goes in, 4 comes out. Okay, so if you mess with the x value, that is going to affect the graph horizontally. Now, I want you to notice what's happening here. If you subtract, notice it moves the graph to the right. Okay? If you subtract, it moves your graph to the right. So one would expect that if we were to change this to adding, the graph would actually move left, and we see it does here. This is x plus 1 squared. Notice it's the same picture, but moved 1 unit left horizontally. X minus 2, x plus 2, x plus 3. Okay, so subtracting on the inside moves your graph to the right. Adding on the inside moves your graph to the left. So subtract, you're going that way to the right. Add, you're going that way to the left. Now, let's see what happens if we keep the inside the same, but we're going to mess with the outside. So we're going to do the squaring and then after the squaring is done, we're going to add something. Okay, now notice what's happening here. That's the original squaring function, because this is x squared plus 0, x squared plus 1 plus 2, x squared plus 3, x squared plus 4, x squared plus 5. Okay, notice the pattern there. That's affecting the graph in the up and down direction. That's affecting the y-axis. And notice it's more direct. You add, you go up, like you would expect. And of course, if we were to subtract, the graph would go down. Okay, so this is how changing x and y values through addition and subtraction affects the graphs of these functions. And in our next video, we're going to apply that to trig functions.